Hello, I'm Martin Anfarovich, a sophomore at Tesla High School. Last year I did Arduino Fest, and this year I helped students with their projects. I noticed a repeating pattern of mistakes and setbacks. I'm making this video so you can learn to avoid them. Getting an error after trying your hardest can be very discouraging, but don't despair. An error is not the same as a bad grade. Errors are a normal part of coding for even the most experienced engineers. Being a good coder is about figuring out your errors without blaming yourself or feeling bad. In Arduino Fest, I see three types of errors: compiler errors, logic errors, and wiring errors. The computer displays a red compiler error if it doesn't understand your code. Before we fix it, make sure the code isn't a jumbled mess. Right-click and select Auto Format to indent your code. Add some whitespace so it's easier to read. Click Upload to recompile. Before trying anything, read the error message, unqualified ID before else, and expected declaration before closing brace token. That's computer talk for there's a problem with the braces relating to the else statement. This is our if body, the code that runs when the if condition is true. All code bodies need to start and end with a curly brace. That's the error. We must add in an opening curly brace to match the closing curly brace here. Remember the steps. Clean up your code, read the error message, find and fix the problem, and try compiling the code again. Repeat as necessary. If your code successfully uploads but doesn't do what you want, then you might have a logic error. To fix it, we must first understand our code. Rename confusing variables to names that make sense. This variable stores values read from a potentiometer knob. Renaming it to knob input makes more sense. Then add some quick comments to clarify your code. Next, add in print statements throughout the code to confirm different parts are working as you think they are. Let's print knob input to confirm it actually changes when we turn the knob. Open the serial monitor and test it out. Oh no, it's not changing. We've narrowed down the problem. The potentiometer is connected to A0, but we're reading from A1. Let's fix this to A0 and re-upload. Yay, we fixed it. Remember the steps. Rename confusing variables, add quick comments, add prints, find and fix the problem, re-upload. Repeat as necessary. If all your prints are printing what's expected, but the project still isn't working, then you might have a wiring error. I like to think of electricity as air pressure. The 5-volt pin always pumps out high air pressures. Number pins can be programmed to pump out air pressure using digital write or analog write. The ground pin, also known as GND, negative or minus, is like a hole for pressure to escape. Under the breadboard is this pattern of connections. These two pins are connected and these aren't. Too much pressure can destroy an LED, so we must use a resistor to slow down the current. In this circuit, digital write high sends pressure to pin 4. It flows through this wire to the resistor, which slows it down. The gentle pressure flows through the LED into this wire and to ground. The flow is what makes the LED light up. Pins starting with A don't pump, but can analog read to see how much pressure is flowing into them. Turning a properly wired potentiometer changes how much air pressure flows to its center wire. This wire is connected to pin A0, so we can use analog read to see its changing pressure. To find wiring errors, compare your wiring to the diagram. Follow with your finger where the air pressure is flowing to confirm electricity is getting where it should. Make sure your LED is oriented so its short leg leads to ground. Ensure you have the right resistors and components. Repeat as necessary. If you've done all this and still have a problem, don't just blankly sit there waiting for an angel to come. Ask one of your peers. Don't be shy, there's no such thing as a dumb question. Be specific and explain everything you've tried. If someone asks you for help, be respectful and don't make fun of mistakes. Try the debugging steps I talked about. After you help fix the problem, make sure the person fully understands what you've done. Otherwise, they'll just keep coming back to you for help. Asking and answering questions helps everyone make progress and new friends. Experienced engineers always work together and help each other out. You'll have to finish your code sooner or later, but I recommend sooner. Getting it over with faster means you'll have time to try new things or help others. I hope this advice helps, and good luck.